Okay, this is the second part of the video where I give answers to some of the questions from the Chapter 6 and Chapter 8 review packet. We're now moving on to Chapter 8. First batch of questions that you got in that review packet was use the product of powers property to simplify. And the first question we're going to do is this very first one here, 4 times 4 times 4. Well, we've talked about exponents and the idea that an exponent is really just shorthand. 4 to the third is the shorthand way of saying 4 times 4 times 4. It's just an easier thing to do. So imagine if it had been a string of 17 fours. It's really a pain in the neck to write them out that way. It's much easier to write 4 to the 17th. And that's why we have exponents in the first place, is to save us the trouble of writing that much. But all that 4 to the third means is 4 times 4 times 4. Well, vice versa is also true. All that 4 times 4 times 4 means is 4 to the third power. Let's move on to another example, a little more complicated, number 9 here. I've got x times x squared times x to the third times x to the fourth. Well, let's write each of those out. X stays the same, but x squared is the same thing as x times x. X to the third is the same thing as x times x times x, and x to the fourth is represented here. Well, look at how many x's I have here in this string. You can count them off if you want. 2, 4, 6, 8, 10. It's x to the 10th. And I'm sorry about the way my pen works, but that's supposed to be saying x to the 10th right there. Well, notice what we had from the very beginning. We didn't have to write this whole line out here. We could have just added the exponents. The exponent here is 1. 1 plus 2 makes 3. 3 plus another 3 makes 6. 6 plus 4 make 10. Excuse me. And so we have x to the 10th. Okay, the next power that I had you learn for exponents was the power of a product property. You do not need to know these names. I will not have this be a vocabulary test, but I want you to know how to do the work that's required here to simplify these expressions. So we'll start with this first example. In parens, I've got 4 squared. Well, in parens squared, the exponent goes to whatever it's next to. In this case, it's next to the parens. Inside the parens, there's just 4. So it's really going to the 4 itself. So what you have written here is the same thing without the parens. It's 4 squared. Well, we've already heard this. 4 squared is the same thing as 4 times 4. And you know what 4 times 4 is. This time it's not x times x. Go ahead and multiply it out. 4 times 4 is 16. Now, I'm not saying you have to do all of these steps. You don't have to go from here to here to here to here. I write out all the steps so that everybody can see what I've done. But if you want to go straight from here to 16, fine by me. Let's move on to a more complicated example, number 18. There's a longer way to do this and a shortcut. Let's start with the long way. I've got inside the parens, I've got x to the 6th, x to the 6th, y to the 3rd, and all of that raised to the 3rd power. Well, the 3rd power out here means that I've got 3 sets of these things that are in parens. Remember, this is just shorthand so that I don't have to write this out 3 times. Well, let's go ahead and see what it would look like if I did write it out 3 times. I've got 3 sets now of x to the 6th times y to the 3rd. And now, if I want, I can put the things that are like each other next to each other, and I can add their exponents. The x's, there's a 6, another 6, and another 6. I add up all those exponents. The y's, I've got a 3, another 3, and another 3. I add up all of those 3's. 6 plus 6 plus 6 is going to make 18. 3 plus 3 plus 3 is going to make 9. And this answer is going to end up being x to the 18th, y to the 9th. But let's see how we could have gotten there through the shortcut. I could have distributed this 3 on the outside to everything inside. That would have made it x to the 6 times 3 and y to the 3 times 3. 6 times 3, that same 18 that I was just talking about. It's x to the 18th. And the 3 times 3 is that same 9. So whether you did it down through the long way and add up the 6's to get 18, add up the 3's to get 9, or whether you did it the shortcut way where you multiplied to get there, just make sure you understand how to get there one of these two ways, so that either way you end up with this as your final answer, x to the 18th, y to the 9th. Let's move on to the next the next category of questions. In this case, you're supposed to simplify again. We'll look at number 19 first. 4 squared times 4 to the 3rd power. Well, this is really 4 times 4, and that's a string of 3 4s. Well, instead of writing 4 times 4 times 4 times 4 times 4 and getting 4 to the 5th, what I want you to get used to is adding those exponents. 2 plus 3 gets me there a whole lot faster. I end up with 4 to the 5th. But if you don't see it that way and you want to write it out this way over here, you're certainly welcome to. This is 4 to the 2nd power. This is 4 to the 3rd power. You add how many 4s you have up, and you find out that your exponent's going to be 5. Either way, you should end up with 4 to the 5th power as your final answer. Okay, the next one. Well, 24 actually turns out to be a more complicated problem than I had realized it would be. Certainly something that I did not teach you and will not expect you to know for the final. So instead we'll do 23. 24 actually has you go one step beyond foiling to take the answer from your foiling and multiply it times another binomial. We're not doing that for the final. So let's stay here with number 23. In parens, well, I've just rewritten it here so it's a little easier to read because my writing's a little larger. Negative 6 x squared y, all in parens, to the 3rd power, all in another set of parens to the 7th power. First of all, distribute that 3 to everything inside. I've got negative 6 to the 3rd power. I've got x squared times 3. And I've got this y here also to the 3rd power. So everybody inside the parens has gotten served by this 3, has had this 3 distributed to it. Now this whole thing, in this case now I've moved the 3 inside, so I've got double parens. I don't need double parens. To the 7th power. But now I can distribute that 7 to everything if I want to. Here I've cleaned it up and gotten rid of the parens. I guess I broke this into 2 steps. And then I'm going to distribute the 7 to everything inside. So now I've got negative 6 to the 3 times 7, which is going to turn out to be negative 6 to the 21. X to the 6 times 7 becomes x to the 42, and so on. Your final answer right here, negative 6 to the 21st power, x to the 42nd, y to the 21st. Okay, last batch of questions here. Again, simplify. This last part here, evaluate when x is 2 and y is 2. I forgot to plug those in, so I'm going to have to talk this through. I don't have this written on the slides. But we're going to do the first question here, number 31. All right, this first one here, y squared times y to the 4th. Add those exponents, 2 plus 4. You end up with y to the 6th. Now, I went ahead, actually, I paused the video, and I've done what I said I hadn't done. I've gone ahead and solved by plugging in either x or y as 2. Well, in this case, it's just y. So y to the 6th becomes 2 to the 6th, and you would need to use your calculator probably to find this out. 2 to the 6th turns out to be 64. We'll move on to one more example over here, number 36. Y to the 4th times y to the 1st times x to the 4th. These exponents you can add because the bases are the same, the y and the y. So you can make this y to the 4 plus 1, or in other words, y to the 5th. On the right side, it stays what it is, x to the 4th. You cannot add these. So the simplified part of your problem is done here. Y to the 5th, x to the 4th. That's as far as you can simplify. You can't put the x and the y together. It's apples and oranges. But when it comes to the next step, then evaluate. Well, now I can put 2 in here for y and 2 in here for x. And so I'm going to have 2 to the 5th times 2 to the 4th. Now the bases are the same. Now I can add the exponents. And so 5 plus 4 becomes 2 to the 9th. And now it's completely simplified. And the only way I can go beyond this is to use a calculator. And if I plug 2 to the 9th into a calculator, I'll find this turns out to be 512. Okay, that's it. Those are the questions that I wanted to help you with. Hopefully, you will find that you can do all of the other problems that I haven't covered here. If you have any questions, don't hesitate to come into class and let me know what those questions are.